Welcome to Ask and Learn.
We're asked to plot various functions that have the form y equals e to the minus bx squared. We can take a derivative and a second derivative, and we can see that we have a critical point always at x equals 0. There's always just one right at the origin. And that's pretty clear because that's, no matter what b is, it's e to the 0. And so all of these functions go through 0, 1. And then we have extrema points if we take a second derivative at square root of 1 over 2b. So those change depending on what b is. And so as b gets smaller, the inflection point moves out. So if b is 1, then we have an inflection point at 1 over square root of 2. Let's see, square root of 1/2 is, what is that? No. Square root of 1/2 is 0.7, right? I should know that by heart by now. So, we have an inflection point. Here's 1 around here, 0.7, so like right around in here. That looks about right. Clearly, we can see that as x gets very big, this thing gets very negative, and that means this thing gets very small. So we always go approach 0 as x gets very big in either direction. So the magnitude of x gets big, we always go to 0. And then what we can see, so the inflection point moves in and in and in. So basically what we're seeing is that we get kind of a steeper and steeper peaks here. And so these are what usually are just, looks like a Gaussian distribution almost. So, we use these kind of as distribution functions. So you can think about this, if you have a distribution of values of something, this would be a distribution function. Normally you would say that the integral under this is going to be 0. Oh, not 0, 1, so that basically you have a total probability of 1. But you would then just multiply this by a factor to normalize it. So, and then this is kind of like, looks like the standard deviation, right? How wide this is. So how much variance you get. And so as b gets bigger and bigger, you get basically sharper and sharper peaks. And in fact, if you go on in math, as b goes to infinity, this becomes basically what you call a delta function. That it just basically it's 1 when x equals 0 and 0 everywhere else. As b gets very, very large, you approach that type of function.